Okay, so here we have an example of Charles's law. We're told that a sample of gas has an initial volume of 2.25 liters and an initial temperature of 500 decimal point Kelvin. If pressure and number of moles of the gas are held constant, what is the final temperature of the gas if the volume decreases to 4.25 liters? So this is, as we said, Charles' law, which states V1 over T1 equals V2 over T2. And so in this case, we know that the V1 is 2.25 liters. We know that T1 is 500 decimal point Kelvin. Important that that decimal point is there to show us that there's three significant figures, and important that we're in Kelvin because remember we always need to be in Kelvin for gas law work. So fortunately we were not in Celsius and we didn't need to do the conversion, and I would never give you Fahrenheit in a gas law problem. Okay, that all equals our final volume of 4.25 liters, and the temperature is now our unknown. So there's a couple different ways we could do this, but it's probably most traditional if we would just try to isolate temperature first. So let's multiply both sides by T2, and now we'll get rid of temperature on the on the right hand side. We've moved it over to the left hand side. If we go ahead and calculate that 2.25 liters divided by 500 Kelvin, we end up with T2 times 0.00450, and that's now liters per Kelvin, and that will equal our 4.25 liters. Obviously we want T2 isolated, so we'll divide both sides by the 0.00450 liters per Kelvin, and that's going to mean that our unit of Kelvin is in the denominator of our denominator, so it's going to become the unit in the numerator, and we're going to lose liters to cancellation. Okay, so our final value for T2 is going to be 944.444 repeating. And of course we have to consider that this is multiplication and division sig fig rules, so the number of sig figs is the least number of sig figs in our starting values, and all of our values here have 3 sig figs, so our final answer needs to have 3 sig figs. 944.4, the 0.4 is less than 5, so that means our final answer should be 944 Kelvin. All right, and that's how we do Charles' law. So hopefully if you've been having trouble with a Charles' law type problem, this will give you an example. The other alternative, we could have had the final temperature and solve for the final volume, but it's the same sort of approach. Okay.